So, a question at the beginning of our class today was about this problem from the homework, which asked you to verify that the vector CP is perpendicular to both QR and QS. And the question is, what does this mean about the cross product of QR with QS? So, if the conceptual part of this question is at issue, so this clause here at the end, what does this mean about the cross product? Then here is my hint on this, is that we figured out yesterday about what we can do to find a vector that is perpendicular to a pair of given vectors. And the cross product was the way to determine a vector that's perpendicular to a given pair of non-parallel vectors. And so my hint for this, I guess, is to see if you can leverage that connection. Well, maybe let me put it this way. I'm going to switch over my whiteboard for a second, just to give myself a little bit more room to jot stuff down. So, one of the cool things about 3 dimensions is that it's the only number of dimensions in which, if you give me 2 vectors that are not parallel, so you give me a v, maybe it looks like this, and you give me a w that's not parallel to v. So, who knows, maybe there's my w. If you give me 2 vectors in 3 space, those 2 vectors uniquely determine, and here might be another hint for the homework problem that you're asking about, these 2 vectors uniquely determine a line's worth of vectors that has the property that that line is perpendicular to both of my originals. So this line is perpendicular to v, this line is also perpendicular to w. So 3 dimensions is the only number of dimensions in which that works, and so it's the only dimension in which we can determine a cross product and have it come out as being a unique vector. Remember, the cross product is characterized not just by having a direction that's perpendicular to v and w, but also having a particular magnitude that's determined by the area of the parallelogram that v and w determine. So in this case, I think using the right-hand rule, I'm going to try to get my hands in the right orientation here, that since v is here and w is there, that the cross product is going to be facing upwards on this diagram. So I think we would find the cross product of v with w somewhere in here, likely. So there's my cross product, v cross w. And so coming back to the homework question, once we know that the cross product of v with w is a vector that is perpendicular to both of my original vectors, once we know that CP is perpendicular to both QR and QS, there's probably some relationship between CP and the cross product of QR with QS. Back to the whiteboard one last time. It's a bit like saying if you hand me a vector, let's call it z or something like that, and my vector z is perpendicular to both v and w, maybe this is my z. Z, question mark. Or maybe my z points in the other direction. Maybe it's over here. Right? So I don't necessarily know anything from this statement about the length of z. I only know something about its perpendicularity to v and to w. And so if z is perpendicular to both v and w, what relationship does it probably have to the cross product of v with w? It might not be equal, but what's the slightly less restrictive thing that we can say about the relationship between z on the one hand and the cross product of v with w on the other hand?
It's going to be parallel or anti-parallel?
Parallel or anti-parallel. Yeah, so that's a geometric way to say what the relationship of z to v cross w must be. And how would you write that as an algebraic statement? So either z is parallel to v cross w or anti-parallel. And so what does that mean as an equation or as an algebraic statement? what vector operation can we do to a vector that always produces a new vector that's either parallel or anti-parallel to the original?
The cross product?
Well, the cross product produced
Hmm.
a vector that was perpendicular to both v and w, but it has a prescribed
Right.
length, right?
Hmm.
So I'm looking for something even more elementary. And what I'm looking for here is, let me find the little visual that I like to use for this. I'll switch it over. The vector operation that always gives us a new vector that's either parallel to or anti-parallel to the original. What am I doing to the vector v here?
You're just scaling it.
I'm just scaling it. I'm just multiplying it
Hmm.
by a scalar. So if I know that z and v cross w are either parallel or anti-parallel, that must mean that one of them is a scalar multiple of the other. So there's some scalar c that has the property that z is just c times v cross w. So that's, I think, what this
Hmm.
problem is trying to get at, right? Once we have found that CP is perpendicular to both QR and QS, that must mean that it's a scalar multiple of the cross product of QR with QS. That, I think, is the resolution, the answer that this question is looking for, is to make that connection. And since we just did that together, this is a question I don't know about ClassKick. If I write this in my copy, I wonder if it shows up in your copy. You'll have to tell me. It means that CP is equal to a scalar multiple of QR cross QS. Oops. Scroll that over so you can see it. Looks like it's running off the page a little
It
bit.
showed up in mine.
It did show up in yours. Cool. I like ClassKick. It does a lot of neat stuff. So hopefully I didn't write over anything that you had already written. I tried to keep it off to the side. But yeah, so now that hint will appear in everybody's copy of this homework.